my name's Josh, and today we're going to be looking at quadratics. Now, I'm sure within your studies you would have encountered functions, so y equals, that look something like this, 3x plus 7, or y equals 2x. But what you may have not came across is something such as this, or maybe this. So those above these two are what are known as linear functions, and linear functions simply produce straight lines on a graph. Quadratics, on the other hand, which are these here, produce what is known as a parabola when sketched. So now let's have a look what quadratics look like. So a quadratic could look something like this. It could also look something like this. And last of all, could also, running out of space, look something like that. As you can see, this one is different. This one here is different to this one here because it hits the x-axis twice. This one is different because it only connects with it once. And this graph here is different because it is almost the other two graphs rotated 180 degrees. So you get a smiley face graph when there is a positive for the x squared, and you get a upside down face graph such as this one when there is a negative in front of the x squared. So you just need to keep that in mind for when you draw them. So now let's look at the actual roots and how to factorise a quadratic. So say if we have a quadratic such as this. We have x squared plus 6x plus 9. Now the principal rule of quadratics, for those that don't have a number before the x squared, is that this number is a product and this is the sum. They must be equal. So what this means is, what I've wrote there, is that you must have two numbers which multiply to give 9, but these same two numbers must add together to give 6. So let's write our factors of 9. So 9. We've got 9 and 1, 3 and 3. 9 and 1 add to give 10, 3 and 3 add to give 6. That works, that doesn't. So we have our two factors. So in order to write this in the appropriate form, the question would say x squared plus 6x equals 0, so we would say x add 3 equals 0. So what this means is our two factors, x equals minus 3, x equals minus 3, obviously they're the same, so we can just cancel one out. So what we've got there is our solution to our factor. Well, we've got that by simply setting x plus 3 equal to 0. Okay, now when it comes to plotting what we've just done, let's get our axis going here. We have a y and an x. Well, we know that's going to be a smiley face graph because it is a positive x squared graph. We know that it's going to have only one hitting the axis, only one root, and we know that this goes at minus 3. But in terms of knowing where our y-intercept is, that's another problem. So as the question will be written as y equals x squared plus 6x plus 9, in order to find out what our y-intercept is, you just set x equal to 0, therefore y must equal 9. You could also do that by just looking at the number without an x, which would just be the 9. So let's plot this. So we have 9 here, and we have our minus 3, which is going to come across here, and we simply draw our smiley face with it dipping the bottom and coming up like that. And there you have it, we have our graph of x squared plus 6x plus 9. Now let's get into another example. And so now we're going to use the expression of x squared minus 9x plus 14. So once again we need two numbers product is the 14, add to give minus 9. So now we're going to say, oh, let's list our factors of 14. So 14 and 1, 7 and 2. Obviously there, 14 and 1 equals 15, and 7 add 2 equals 9. But wait, we've only actually produced our positive values. Remember that you can also have negatives that produce 14. So you can have minus 14 and minus 1. And you can have minus 7 and minus 2. Because remember, the key thing to remember is that two negatives equal a positive. So, if we go through all these, the only one that hits the number before the x, which hits both of these, is the bottom one, minus 7 and minus 2. So now, we technically have our two factors, which is x. Sorry, I've done that wrong. Do that. We have x minus 7, x minus 2, and that equals 0. If we set both of these equal to 0 individually, you have x equals 7 and x equals 2. Those are our two factors. So, we've now got our two factors. Let's draw our graph. So, once again, we know that we have a factor, we know our two roots are 7 and 2 based on what we've just done. We know our y-intercept is 14 because it's just a number on its own. We're going to put 14 there. We know that it hits 2 here and 7 here. So now it's going to hit the graph twice because we have two unique roots, and the graph is going to look something like that. And it hits it at 2, 7 and 14. And there you go.